Students, we will continue with the class on particle in a 3D box, which we were discussing earlier. So, if I just recapitulate briefly, so we were considering the motion of a particle confined in a 3D box whose dimensions are of the sides of the box are of length A, B, and C, and there was no force acting on the particle inside the box. So the potential energy of the particle inside the box is zero, and at the boundaries the potential is infinite, so it is not possible for the particle to cross the boundaries of the box. So there is no existence of the particle outside the box, and so we saw that the wave function was zero outside the box and the wave function existed only within the limits of the box. So using these conditions, actually in my last lecture we have already solved the Schrodinger's equation, and we have put in the boundary conditions and we have got the solution. The eigenfunction looks like this and the energy eigenvalue looks like this. So here A, B, C are the dimensions of the box, and this n1, n2, n3 they are constants, they are integers, and the values of n1, n2, n3 they start from 1, 2, 3 and so on. They cannot, none of them can have the value 0, because if you put the value 0 here, then the eigenfunction will become 0. And the energy eigenvalues also we have worked out. So it looks like this, where h cut we know is h by 2 pi, h is the Planck's constant, m is the mass of the particle, and these symbols, as I've already explained, they have the usual meanings. So this is how the function, the eigenfunction and the energy eigenvalues will look like. Now if it is a cube, if the box is a cube, then of course this A, B and C, all the three sides will be equal, and say I just write it to be equal to A, or maybe L, I write it equal to L. So then the wave function, how it will look for a cube box, for a particle confined inside a cube, it will be 2 root 2 divided by root over of L cube, and it will be sine n1 pi by L x sine n2 pi by L y and sine n3 pi by L z. And the energy eigenvalues, so here it will be pi square h cut square by 2m L square into n1 square plus n2 square plus n3 square. Okay, this is how it will look like if the particle is confined in a cube. Now we will discuss the eigenfunction and the energy values at the different states of the particle. So let's start with the ground state. So you can well understand that for different values of this n1, n2, n3, the function will look different, same as we will get different eigenvalues. So for different combinations of this n1, n2, n3. So the lowest possible combination of n1, n2, n3 is each of them being 1, 1, 1 and 1. So let's work it out for n1, n2, n3 equal to 1. So I will deal with this expression as it looks simpler. So I will deal with this expression. So I will just write down here the different combinations of n1, n2, n3, and then you will realize the different eigenfunctions and then eigenvalues. So n1, n2, n3, all three, when they are 1, 1 and 1, then that is called the ground state. This is called the ground state. So when they are 1, 1 and 1, now the form of this psi will be, so if I just write here psi 1, it will be 2 root 2, if I just write here psi, it will be 2 root 2. So I write here psi 1, 1, 1. It will be 2 root 2 by root over of L cube sine pi x by L sine pi y by L sine pi z by L. And what is the corresponding energy eigenvalue? So 1, 1, 1 here. So it is 3 by 2 pi square h dot square by m n square by 2 m n square. Okay, this is the ground state energy, the lowest energy. Now we go to the next possible combination of N1, N2, N3. That will give us the first excited state. So first excited state, so I take a combination 2, 1, 1. Okay. So if I take this combination 2, 1, 1, then psi 2, 1, 1 will be, so I'm just writing this, the same term that I will get. So here it will be sine 2 pi x by L, sine pi y by L, and sine pi z by L, and the energy will be, so it will be 6 by 2, right? If you put here 2, 1 and 1, 2 square 4 plus 1 plus 1, so it is 6 by 2 pi square, so E1, E2 by M L square. Okay, so this will be, E2 here will be 6 by 2 pi square H cut square by M L square. So I get a value of the energy for these combinations of N1, N2, N3. But there can be other combinations also of these quantum numbers N1, N2, N3, for which we will get the same value of the energy. Just take a note. I wrote here 2, 1, 1. If I just recombine this and I write it as 2, 1, 2. Okay. Then also the value of energy will be what? 1 plus 4 plus 1. I will get the same value of energy. So whether it is for 2, 1, 1 or 1, 2, 1, I am getting the same value of energy. Okay. 6 by 2 pi square H cut square by ml square. Okay. But what will the eigenfunction look like? Eigenfunction now becomes, this term remains unchanged, but it is sine pi x by L, sine 2 pi y by L, sine pi z by L. Right? So definitely this is a separate function. It is sine 2 pi x by L, sine pi y by L, sine pi z by L with a constant. Is not the same as the second function which I have written here. These are two separate eigenfunctions, but the energy value is same. Right? Now similarly, I can get another combination. I think you can already guess that there can be a combination like 1, 1, 2, which will also give me the same energy value. The value is same. 6 by 2 pi square H cut square by ml square. But the wave function for this also has a separate form. It looks like sine pi x by L, sine pi y by L, and sine 2 pi z by L. So for a specific energy value, I am getting 3 different eigenfunctions for 3 different combinations of the quantum numbers N1, N2 and N3. So I will say that this first excited state is a threefold degenerate state. It is a threefold degenerate state, and there is degeneracy in this state because for one particular eigenvalue I am getting 3 different wave functions. So it is a threefold degenerate state. But in the previous case, for the ground state, as you can see, that there is only one such combination possible because all 3 there were 1, 1, 1. So there the energy eigenvalue, I can write it as E11. It is the ground state energy value or the 0 point energy we call it. And for that I have only one such wave function is possible. So it is a non-degenerate state and this is a degenerate state. How many fold degeneracy? The number of combinations I can get. So here 3 such combinations are possible. So 3-fold degeneracy. Right? So now let's take a look at some more states and see how it works. So the next energy level I can think of, the second excited state I can think of is say a combination of 2, 2, 1. Okay. For that the energy value will be 9 by 2 pi square H cut square by M L square. Okay. So for 2, 2, 1 and 1 writing again, so I will get an eigenfunction as psi 2, 2, 1 where it will be 2 root 2 by root over L cube sine 2 pi x by L sine 2 pi y by L and sine pi